students, and welcome to the lecture on Introduction to Computer Organization. After this lecture, we will be able to learn the following objectives. Define the introduction to computers. Explain the number representation and binary code. Understand the IEEE standard. Discuss the digital computer generation. Define about buses and bus arbitration. Let's start with the introduction to computer organization. Computer organization deals with the functional behavior of a computer system as viewed by a programmer, like the size of a data type, 32 bits to an integer. Computer organization deals with structural relationships that are not visible to the programmer, like clock frequency or the size of the physical memory.
Personal computers, or PCs, are composed of a number of physical components, known as the computer's hardware. These components include the Central Processing Unit, or CPU, a range of input and output devices, two main types of memory, and storage devices. Let's take a look at each of these. The Central Processing Unit, or CPU, is the part of the computer that performs calculations and carries out instructions. It is sometimes called the processor and is a silicon chip located inside the system unit. It acts like a tiny fast calculator, processing information that flows into it, or input, and generating and forwarding information, or output. A peripheral device is any device you can add to and use on your computer. These devices can be either input or output peripherals. To put information into your PC, you need an input device. The keyboard and the mouse are the two most common input devices. Computer systems can have many different output devices, each converting data into a readable form. The two most common output devices are monitors and printers. Memory is the place in the computer that temporarily stores information while it is being processed. The two main types of memory are random access memory, or RAM, and read-only memory, or ROM. RAM is used to store temporary data. It contains all new data entered since you last saved your work. RAM changes constantly, and its contents are lost when the computer is switched off. The contents of ROM are secured during manufacture and are permanent. For example, ROM stores data containing the instructions needed to get the computer working properly as soon as it is switched on. Virtually all computers have a hard disk. Once a computer is finished processing information, that information must be stored somewhere permanently. The hard disk is a computer's long-term storage device. Information stored on the hard disk remains there even when the computer is switched off. There is a range of removable storage devices available, including diskettes or floppy disks, zip disks, CDs, DVDs, and removable cartridges or digital tapes.
There is a concept of levels in computer architecture. The basic idea is that there are many levels at which a computer can be considered, from the highest level, where the user is running programs, to the lowest level, consisting of transistors and wires. Computer architecture refers to those attributes of a system visible to a programmer, or put another way, those attributes that have a direct impact on the logical execution of a program. Computer organization refers to the operational units and their interconnection that realize the architecture specification. Let's now discuss computers. A computer is an electronic device that can perform activities that involve mathematical, logical, and graphical manipulations. Generally, the term is used to describe a collection of devices that function together as a system. It performs the following three operations in sequence. It receives data and instructions from the input device, processes the data as per instructions, provides the result or output in a desired form. Data. It is the collection of raw facts, figures, and symbols. For example, names of students and their marks in different subjects listed in random order. Information. It is the data that is processed and presented in an organized manner. For example, when the names of students are arranged in alphabetical order, total and average marks are calculated and presented in a tabular form. It is information. Program. It is a set of instructions that enables a computer to perform a given task. Advantages of computers. High speed. Computers have the ability to perform routine tasks at a greater speed than human beings. They can perform millions of calculations in seconds. Accuracy. Computers are used to perform tasks in a way that ensures accuracy. Limitations of computers. Computers need clear and complete instructions to perform a task accurately. Computers cannot think. Computers' major parts. The computer system consists of three units: input device, central processing unit or CPU, output device, input device. This reads information from input media and enters to the computer in a coded form. A CPU has a memory unit. This stores program and data. Arithmetic logic unit performs arithmetic and logical functions. Control unit interprets program instructions and controls the input and output devices. Output device decodes information and presents it to the user. generations. Generation in computer terminology is a change in technology that a computer is or was how it's being used. Initially, the generation term was used to distinguish between varying hardware technologies. But nowadays, generation includes both hardware and software, which together make up an entire computer system. Computers, classifications. Computers differ based on their data processing abilities. They are classified to purpose, data handling, and functionality. Computers are either general purpose or specific purpose. General purpose computers are designed to perform a range of tasks. They have the ability to store numerous programs, but lack in speed and efficiency. Specific purpose computers are designed to handle a specific problem or to perform a specific task. A set of instructions is built into the machine. According to functionality, computers are classified as analog computer. An analog computer is a form of computer that uses continuous physical phenomena, such as electrical, mechanical, or hydraulic quantities to model the problem being solved. Digital computer. A computer that performs calculations and logical operations with quantities represented as digits, usually in the binary number system. On the basis of size. Supercomputer. The fastest and most powerful type of computer. Supercomputers are very expensive and are employed for specialized applications that require immense amounts of mathematical calculations. Mainframe computer. A very large and expensive computer capable of supporting hundreds or even thousands of users simultaneously. Microcomputer or personal computer. Desktop computer. A personal or micro-mini computer sufficient to fit on a desk. Laptop computer. A portable computer complete with an integrated screen and keyboard. It is generally smaller in size than a desktop computer and larger than a notebook computer. Palm-top PC. A palm-top is a small computer that can be carried along in the pocket or briefcase. Personal computer. A personal computer, or PC, is a digital computer designed for use by only one person at a time. Did you know in 1979, William Mogridge of Grid Systems Corporation created the first functioning portable computer, the Grid Compass Computer 1109. Now we will study the number representation and binary code. Binary is a number system which builds numbers from elements called bits. Each bit can be represented by any two mutually exclusive states. Generally, when one writes it down or code bits, one represents them with 1 and 0 to build binary numbers. The same way one builds numbers in the traditional base 10 system. Conversion. The easiest way to convert between bases is to use a computer. After all, that is what they are good at. However, it is often useful to know how to do conversions by hand. The easiest method to convert between bases is repeated division. To convert, repeatedly divide the quotient by the base until the quotient is 0, making note of the remainders at each step. Bits and bytes. To represent all the letters of the alphabet, one would need at least enough different combinations to represent all the lowercase letters, the uppercase letters, numbers, and punctuation, plus a few extras. Adding this up means that one needs probably around 80 different combinations. ASCII. Given that a byte can represent any of the values between 0 through 256, anyone could arbitrarily make up a mapping between characters and numbers. For example, a video card manufacturer could decide that the value 10 represents A, So when value 10 is sent to the video card, it displays a capital A on the screen. Parity. ASCII, being only a 7-bit code, leaves 1 bit of the byte spare. This can be used to implement parity, which is a simple form of error checking. Consider a computer using punch cards for input, where a hole represents 1 and no hole represents 0, 16, 32, and 64-bit computers. Numbers do not fit into bytes. Hopefully, bank balance in dollars will need more range than can fit into 1 byte. Most modern architectures are 32-bit computers. This means they work with 4 bytes at a time when processing and reading or writing to memory. Newer architectures are 64 bits, which doubles the size of the processor and works with 8 bytes, kilo, mega, and gigabytes. Today, kilobytes of memory would be small for a wristwatch, let alone a personal computer. The next SI unit is mega for 106. As it happens, 2 to the power 20 is again close to SI base 10 definition. 1,048,576 as opposed to 1 million. Kilo, mega, and gigabits. Apart from the confusion related to the overloading of SI units between binary and base 10, capacities will often be quoted in terms of bits rather than bytes. Boolean operations. George Boole was a mathematician who discovered a whole area of mathematics called Boolean algebra. How computers use Boolean operations. Believe it or not, essentially everything a computer does comes back to the operations. For example, the half adder is a type of circuit made up from Boolean operations that can add bits together. It is called a half adder because it does not handle carry bits. Put more half adders together and one will start to build something that can add together long binary numbers. Hexadecimal. Hexadecimal refers to a base 16 number system. One uses this in computer science for only one reason. It makes it very easy for humans to think about binary numbers. Fixed and floating point number representation. The Institute of Electrical and Electronics Engineers, or IEEE, standardizes floating point representation in IEEE 754. Floating point representation is similar to scientific notation in that there is a number multiplied by a base number raised to some power. For example, 118.625 is represented in scientific notation as 1.18625 times 102. The main benefit of this representation is that it provides varying degrees of precision based on the scale of the numbers that one is using. BCD. In computing and electronic systems, binary coded decimal, or BCD, or in its most common modern implementation, packed decimal, is an encoding for decimal numbers in which each digit is represented by its own binary sequence. EBCDIC, Extended Binary Coded Decimal Interchange Code, is a character encoding set used by IBM mainframes. Unlike virtually every computer system in the world, which uses a variant of ASCII, IBM mainframes and mid-range systems, such as the AS400, tend to use a wholly incompatible character set primarily designed for ease of use on punched cards. ASCII is the American Standard Code for Information Exchange, also known as ANSI X3.4. There are many variants of this standard, typically to allow different code pages for language encoding, but they all basically follow the same format. ASCII is quite elegant in the way it represents characters and it is very easy to write code to manipulate upper, lowercase, and check for valid data ranges. XS-3. XS-3 code is an example of unweighted code. XS-3 equivalent of a decimal number is obtained by adding 3 and then converting it to a binary format. For instance, to find XS-3 representation of decimal number 4, first 3 is added to 4 to get 7. Then the binary equivalent of 7, that is 0, 1, 1, 1, forms the XS-3 equivalent. Let's now understand the IEEE standard, abbreviation of the Institute of Electrical and Electronics Engineers, pronounced IEEE. Found in 1884 as the AIEE, the IEEE was formed in 1963 when AIEE merged with IRE. IEEE is an organization composed of engineers, scientists, and students. The IEEE is best known for developing standards for the computer and electronics industry. In particular, the IEEE 802 standards for local area networks are widely followed. The IEEE has done notable work in the standards area of networking. This organization is huge with over 300,000 members made up of engineers, technicians, scientists, and students in related areas. The Computer Society of IEEE alone has over 100,000 members. It's credited with having provided definitive standards in local area networking. These standards fall under a group of standards known as the 802 Project, executed by the Computer Society's 802 Subcommittee. IEEE Standard for Floating Point Representation. The IEEE Institute of Electrical and Electronics Engineers has produced a standard for floating point arithmetic. This standard specifies how single precision, 32-bit, and double precision, 64-bit, floating point numbers are to be represented, as well as how arithmetic should be carried out on them. Let us now talk about the digital computer generation. First generation, vacuum tubes. The period of the first generation was 1946 to 1959. The first generation of computers started with using vacuum tubes as the basic components for memory and circuitry for the CPU, or central processing unit. These tubes, like electric bulbs, produced a lot of heat and were prone to frequent fusing of the installations. Therefore, were very expensive and could be afforded only by large organizations. Second generation, transistors. The period of second generation was from 1959 to 1965. This generation, using the transistor, was cheaper, consumed less power, more compact in size, more reliable and faster than the first generation machines made of vacuum tubes. In this generation, magnetic cores were used as primary memory and magnetic tape and magnetic disks as secondary storage devices. Third generation, integrated circuits. The period of third generation was 1965 to 1971. The third generation of computer is marked by the use of integrated circuits, or ICs, in place of transistors. A single IC has many transistors, resistors, and capacitors, along with the associated circuitry. The IC was invented by Jack Kirby. Fourth generation, microprocessors. The period of fourth generation was 1971 to 1980. The fourth generation of computers is marked by the use of very large-scale integrated VLSI circuits. VLSI circuits, having about 5,000 transistors and other circuit elements and their associated circuits on a single chip, made it possible to have microcomputers of fourth generation. Fifth generation, artificial intelligence. The period of fifth generation is 1980 till now. In the fifth generation, the VLSI technology became ULSI, Ultra Large Scale Integration Technology, resulting in the production of microprocessor chips having 10 million electronic components. Computer types and classifications. The types of computers range from the hybrid to the analog types. The computers one comes across in the course of day range from laptops, palm tops, and towers to desktop computers, to name a few. But the very word computers reminds one of the desktop computers used in offices or homes. Functional units and their interconnections. A computer can process data, pictures, sound, and graphics. They can solve highly complicated problems quickly and accurately. Input. This is the process of entering data and programs into the computer system. Storage. The process of saving data and instructions permanently is known as storage. Processing. The task of performing operations like arithmetic and logical operations is called processing. Output. This is the process of producing results from the data for getting useful information. Control. The manner how instructions are executed and the operations are performed. A bus in computing is a set of physical connections, cables, printed circuits, etc., which can be shared by multiple hardware components in order to communicate with one another. The purpose of buses is to reduce the number of pathways needed for communication between the components by carrying out all communications over a single data channel. This is why the metaphor of a data highway is sometimes used. Characteristics. A bus is characterized by the amount of information that can be transmitted at once. This amount, expressed in bits, corresponds to the number of physical lines over which data is sent simultaneously. Bus architecture. In reality, each bus is generally constituted of 50 to 100 distinct physical lines, divided into 3 subassemblies. The address bus, sometimes called the memory bus, transports memory addresses with the processor wants to access in order to read or write data. The data bus transfers instructions coming from or going to the processor. It is called a bidirectional bus. The control bus or command bus transports orders and synchronization signals coming from the control unit and traveling to all other hardware components. Types of buses and bus arbitration. The types of buses are local buses. A local bus is the simplest of buses consisting of sets of wires. System buses. Unlike local buses, system buses are independent functional components of many computers. Purpose of arbitration. In a computer system, all the devices that communicate with other devices are connected to the main board over the same bus. If 2 or more I/O input and output devices try to use the bus at the same time to access the main board, there will be a conflict. Therefore, bus arbitration is created to resolve the problem. Now in the end, let us summarize what we have learned in this lecture. A computer is an electronic device that can perform activities that involve mathematical, logical, and graphical manipulations. A personal computer, or PC, is a digital computer designed for use by only one person at a time. Binary is a number system which builds numbers from elements called bits. Each bit can be represented by any 2 mutually exclusive states. In computing and electronic systems, binary coded decimal, in its most common modern implementation, packdecimal, is an encoding for decimal numbers in which each digit is represented by its own binary sequence. Multipoint is a bus topology that carries signals to several destinations. It is also known as multi-drop bus, or MDB, or broadcast bus.